this qualitative analysis note there is a table for test for gases. Okay. Now my students always find this very uh, difficult to predict what type of gases that they should test for. They should identify in a reaction which is producing a gas. So when they see effervescence, then they would not know which gas to be tested. Now, in this table, there are only four types of gases that you will be required to identify. First one is ammonia, second, carbon dioxide, third, hydrogen, and the fourth one is oxygen. So I'm going to show you what type of reactions are going to produce this set of gases, these four types of gases. Now, the first one, hydrogen gas. So in what kind of reactions will produce hydrogen? Okay. So when a question is asking you to add metals to an unknown solution, that metal could be magnesium. Okay, let's say you saw on your table, you are provided with magnesium strips. Okay, and the question actually mentioned that okay, add magnesium strip to 1 cm depth of this solution. And if you see effervescence, okay, the fizzing, bubbles, a gas is produced, then you immediately know, okay, that gas is a hydrogen gas, and I'm supposed to test with, test with a lighter splint, and you should hear the pop sound. If there's no pop sound, there's no hydrogen. Okay, try again because be confident when you're asked to add metal to an unknown solution. Okay, that reaction will produce hydrogen, and that solution is very highly likely an acid. If you see no effervescence, no bubbles, no fizzing, then that solution is not an acid. Okay, then probably you have a few unknowns and other unknowns. One of them could be an acid. Now, the second gas in my slide will be carbon dioxide. So again, when you are asked to add acid to a salt, okay, a solid, then you might want to suspect that, oh, that could be a reaction that is producing carbon dioxide. Okay, acid with carbonate salt will produce carbon dioxide. Now, provided that solid, okay, it doesn't look like a metal, because if it is a metal, then you should test for hydrogen gas. Okay, if it is a colorless, sorry, not colorless, white solid, okay, or a color solid, then you are supposed to test for the presence of carbon dioxide. Okay, if question is asking you to add acid to that solid. So to test for carbon dioxide, if let's say in the exam, okay, you panic, you do not know how should you test for carbon dioxide, please always refer to this table. Again, this table will be given in the exam. So it gives a what precipitate with lime water. So quickly take a, a tube, okay, fill in with 1 cm depth of lime water, delivery tube to the other test tube, which contains your acid and carbonate. Okay, flow the gas into lime water, and you will be able to see the lime water turns cloudy. So we say that the gas gives a wet precipitate with lime water. Now the third one, the gas that I'm going to talk about will be ammonium. So ammonia gas. So there are two reactions in your paper that will produce ammonia. The first will be ammonium salt with sodium hydroxide and heat. So if you are asked to add sodium hydroxide into an unknown solution and you're supposed to warm that solution, ammonia will be produced. Okay, now let us look at the table. Okay, sodium hydroxide with ammonium. No precipitate, but on warming, ammonia will be produced. Okay, this is our first reaction, producing ammonia. Another one also in this table, nitrate or nitrite, okay, ammonia is liberated on heating with sodium hydroxide solution and aluminium foil, right? So let's go back. So if you are asked to add sodium hydroxide to an unknown solution, no precipitate is formed, you are supposed to warm the solution. That means ammonia will be produced. Second one, if the question asks you to add sodium hydroxide and aluminium foil is involved, okay, they ask you to add aluminium foil after that or together and heat, ammonia will be produced. How do you test for ammonia? Go back to the table if you cannot remember. You are supposed to test ammonia with red litmus paper and ammonia if it is produced, okay, it will turn the damp red litmus paper blue. So the piece, okay, wet the litmus paper before it is used. Let's go to the last one, will be oxygen gas. So what type of reactions will involve, okay, um, the liberation of oxygen gas? Okay, any redox reaction involving addition of aqueous hydrogen peroxide will produce oxygen. So if in anywhere in the question you are asked to add hydrogen peroxide solution into an unknown solution, okay, oxygen will be produced. So you are supposed to test this gas, okay, identify this gas with a glowing splint because oxygen will be able to relight a glowing splint, okay, uh, due to its properties in helping the combustion. Okay, right. So this will be the reactions that will produce gases and the gases listed in your qualitative analysis note. Now, I'm going to show you more reactions. I'm going to produce gases, but this I'm going to focus on gases that are formed from heating solids. Because, okay, uh, not all the time you're provided with solution in paper tray. Sometimes you're given solid. So, by heating solids, okay, gases can be formed also. So the first type of gas will be H2O, steam, and steam is formed from heating hydrated salt. So what does it mean by hydrated salt? Okay, salt like copper sulfate. Okay, inside the copper sulfate solid, okay, there are water molecules that trap between the crystals, so they are there and make the solid become hydrated. Now, if you heat this solid, hydrated solid, okay, you are releasing the water from the solid. So they are driven away as steam. So how do you observe this? Okay, the steam will condense at the upper part of the tube, which is colder because you start heating here. So this part is hotter, warmer, this part is colder. So steam that are driven away from the hydrated salt will start to condense to water droplets, okay, near the opening of the tube. So second one, nitrogen dioxide and oxygen, okay, they can be formed from heating nitrates. Group 2 nitrates, okay, magnesium nitrates, other nitrates like copper nitrate, zinc nitrate, normally with a positive 2 metal ion because they are able to polarize the anion and at the end the nitrates are being decomposed to nitrogen dioxide and oxygen. Okay, so here, if you're heating a solid which you don't think is a carbonate and oxide or ammonium salt, you might want to test for nitrogen dioxide. Now, nitrogen dioxide is very easy to identify. It is a brown gas. When you see a brown gas is formed, you test with litmus paper. Okay, blue litmus paper, then blue litmus paper, and it will turn red because nitrogen dioxide is an acidic gas. Once you see brown gas is being formed, please quickly test for oxygen also, because these two gases, they are always being produced together in the heating of nitrates. Carbonates, okay, if you are heating carbonates like group 2 carbonates, then carbon dioxide will be formed. If you are heating oxides, okay, if you can remember, okay, some oxides are black solids. So if you are asked to heat a black solid, then you want to test the gas. Okay, you want to identify the gas as oxygen. Some ammonium salt, okay, without adding sodium hydroxide solution, can actually decompose into ammonia. For example, ammonium chloride. Okay, ammonium chloride, when it is heated, okay, ammonia and hydrogen chloride gases are formed. So if you are asked to heat a white solid, okay, and while you heat, you see white solid forming. Okay, white solid forming near the opening of near the upper part of this test tube. Okay, it's very highly likely that this is ammonium chloride, because these two gases, they will combine, they react with each other and reform ammonium chloride, the white solid. So the white solid start to be deposited, okay, uh, at the upper part of this test tube. So if you see white solid, then you know it's ammonium chloride. Please test for ammonia, okay, when you heat the solid. Okay, now this is a 5 minutes rule here. Why 5 minutes rule? Some decomposition of the solids will take longer time, so do not stop heating so early. Try to heat for at least 5 minutes, so that you'll be able to tell, okay, which gas is produced, and you'll be able to you have enough time to let these gases to form, and you have sufficient gases to be able to be identified. Okay, if very little amount of gases are being produced, you might get a negative result, and that will give you a false observation. So remember this 5 minutes rule. Heat them long enough so that you have more gases that are being formed, and you'll be able to identify them.